Good evening to you all. Myself Sandeep Gogoi, PGT Mathematics from JNV Dibrugarh, Assam. So here I am with you to discuss a very important chapter, that is matrices and determinants. As you all know that from this two chapter we will have 10 marks. So we should not lose any marks from this two chapter, matrices and determinants. And we have to see all the basic things very carefully, right from the definition and properties of matrices and determinants. Now let us see here what is matrix. Now let us consider number x. So here in the slide you have seen, uh, I have taken a number x. Now this can be written in bracket, third bracket or first bracket like this. Okay. Similarly, if I take two numbers, suppose I am taking here two number 2 and 3, and 2 and 3 also can be written in a line containing 2 and 3 horizontally or vertically. So two ways we can write down. Similarly, if I take three numbers 1, 2, 3, here also we can write in horizontal line 1, 2, 3 or vertical line 1, 2, 3. So there are two arrangement again. Now if I take four numbers 1, 2, 3, 4, now four numbers also we can arrange like this. You see here two horizontal line, 1, 2, one line, 3, 4 another line, and two vertical line, 1, 3, and 2, 4. So this is one arrangement. Again, one horizontal line containing all the four numbers, or one vertical line containing all the four numbers. So we are having here three arrangement. If we have four members, now we are having three arrangement. So likewise, here we have seen already, if two elements, so we can write 2 factorials 1 into 2 or 2 into 1. If three number, then 1 into 3, 3 into 1. And four members, 1 into 4, 4 into 1, 2 into 2. So like this, if we have mn numbers, then mn numbers can be arranged in m horizontal lines and n vertical lines. Now here horizontal lines are known as rows and vertical lines are known as columns. Okay. So horizontal line is known as rows and vertical lines are known as columns. Now here we have seen, if I go back, now here two members, so two ways, because two numbers can be written into 1 into 2. That means we can write one row, two columns, or 2 into 1. Two rows, one column like this. 2 into 1 or 1 into 2. Similarly, if we have three number, then again 3 into 1 or 1 into 3. Like this we can write down. Or four numbers. So four member, so we can write 4 1 into 4, 4 into 1, or 2 into 2. Now here 1 into 4 means one row and four column. So one row, four column, we can write down here, you see four column and one row. Similarly, 4 by 1 means four rows. 1, 2, 3, 4, and one column. 2 by 2 means two rows and two columns. So in this way, you can write down. So here, uh, if there are mn elements, so if mn elements, then we can write into m rows and n columns. Okay. Suppose we are having mn elements. We are having m into n elements. So mn elements we can write in m rows and m columns. So m by n. So here m rows and columns. So m by n is known as order of the matrix. M by n is known as order of the matrix. Okay. Now here, next we can see here, before going to equality of matrix, now here we can see uh, a matrix of order m by n. How we write in short form? We can write aij, okay, m by n. So here I denote the ith row and j denote the jth column. Okay. So here Aij means if the element belong to ith row and jth column, so we can write it as Aij. Or simply, if we write a matrix of order 3 by 3, we can write in this way. 3 rows, 3 columns if I take. Elements can be written. You see, in the first row, we'll have first row 3 members. So A11, A12, A13. Second row, A21, A22, A23. Third row, A31, A32, A33, like this. So in short, we write it as Aij of order 3 by 3. Okay. So writing a matrix in general form, that is Aij. So we are writing in terms of Ij. But particularly if we want to write, then we can write A11, A12, A13, A21, A22, A23, A31, A32, A33, right? So here you must have understood A32, the element belongs to third row and second column, like this. A21 belongs to second row, first column. Okay. Now here, now come to equality of matrices. Now equality of matrices, equality. Two matrices A equal to Aij, B equal to Bij are said to be equal if they are of same order. Their order must be same. If A is of order m by n, B also must be of order m by n. And secondly, each element of A is equal to the corresponding element of B. That is Aij equal to Bij for all Ij. That means A11 equal to B11, like this. A21 equal to B21, etc. So this equality of matrices is very important. So next is, for example, we are taking two equal matrix. So you see the order of the matrix, isn't it? You can identify what is the order here. We are having two rows and, isn't it? Two rows and three columns. Here also two rows and three columns. So 2 by 3. This is also 2 by 3. Then if they are equal, so equal means we are taking equal. This matrix equality sign. So this equal to the other matrix. So here corresponding elements are equal. So by equality of matrices, we must get A equal to 1, B equal to 2, C equal to 5, like this, X equal to 7, Y equal to -1, Z equal to 4. Okay. So on equality of matrices, we may get a question like this. Next is, we can construct also matrix. Is it? So sometime we may get in exam the construction of matrix. Constructed 2 by 2 matrix. Ah, order is 2 by 2. So element properties like this. Aij equal to I plus j square by 2. Aij is I plus j square by 2. So here I and j are indices. So 2 by 2. So A means A11, A12, A21, A22. Now A11 means I also 1, J also 1. So we can have 1 plus 1 whole square by 2. That is 2 square by 2 will get equal to 2. A12, 1 plus 2 square by 2 means 9 by 2. A21 also similarly 9 by 2. A22 is 16 by 2, that means 8. Now we can form the matrix as 2, 9 by 2, 9 by 2, 16 by 2. Okay. So construction of it may be of 2 by 3. So we'll have 2 by 3 means how many members? 2 into 3, 6 members. So we have to find out 6 members. Okay. Now operation on matrices. Now operation on matrices here, like in basic operation on numbers, we know addition, subtraction, multiplication, and division. Now here also addition of matrices. Now we can add two matrices. We can sum. The sum of two matrices is a matrix obtained by adding the corresponding element of the given matrices. Furthermore, the two matrices have to be of same order. That means they must be of same order. Okay. So two matrices can be added. First and foremost is equal order. They must be of equal order, same order. Otherwise, we cannot add two matrices. For example, here you see we are taking A as a matrix of 2 by 2, B is a matrix of 2 by 2. So we can find out A plus B by adding the corresponding element. So we'll get a matrix of same order 2 by 3. Okay. A plus B is another matrix is of same order as A and B. So here we can get the matrix A plus B by adding the corresponding elements. A11 plus B11 first element. A12 plus B12 second element of first row. A13 plus B13 that is a third element of first row. Like that we can find out. Next, difference also same way. We can find out A minus B by subtracting their corresponding elements, and this can be done only if A, B of same order. Difference of two matrices Aij, B, Bij are can be done if they are of same order, same by n. So we'll get a new matrix A minus B D is also of same order. Element suppose Dij. So Dij is obtained by Aij minus Bij. So we can subtract the corresponding elements. Now multiplication of a matrix by a scalar. This is very important. If we multiply matrix by a scalar k, then we have to multiply each element of the matrix by the scalar k. That means k into A means k into matrix Aij is matrix k into Aij of order m by n. Okay. That is ijth element of k is k Aij. So this is the multiplication matrix by scalar, which is very, very important property. Now, for example, we have seen A we are taking is 2, 4 minus 2, 5, 7, 1. Then you are multiplying 2 with A. So 2A means 2 into 2, 4, 2 into 4, 8, 2 into minus 2, minus 4, 2 into 5, minus 10, 2 into 7, 14, 2 into 1, 2. Now, property of matrices, we can see here matrix addition. If I see A plus B equal to B plus A, we will get. And matrix addition is also associative. A plus B plus C equal to A plus B plus C. Now here one important thing is zero matrix is the additive identity for matrix addition. Means for any matrix A of order m by n, then we must be a matrix zero matrix of order m by n such that we'll get equal to A itself. So zero is known as your zero matrix is known as your additive identity for matrix addition. Now, very, very important is matrix multiplication. Okay, two matrices A and B can be multiplied only if column of A must be equal to rows of B. Okay, column of A is equal to rows of B. Then only we can multiply A into B. So column of first matrix, that is A, must be equal to row of second matrix, that is B. The order of resultant matrix is equal to number of row of matrix A by number of column of matrix B. Okay, so we'll get a new matrix. Now here you see I'm taking a matrix of order m by n and B is of order n by p. So you can find out A into B because here column of A is n, row of B is n. Now A by B is nothing but m by p. Okay, A by B is nothing but is a matrix of order m by p. So next is how to multiply. Okay, how to multiply we should not uh, forget. It's very, very important because it is required everywhere in solving a pair of linear equation. Is matrix multiplication is very, very important. Now here let us take two matrices A and B. Suppose here column of A equal to row of B. Then we'll get a new matrix C, which is obtained by multiplying A and B. Now, how we'll multiply here, you see. Now, here, element of first row is obtained by multiplying the corresponding element of first row of first matrix with column of first column of second matrix. So first row element, we multiply first row of first matrix with first row of second matrix. Similarly, second row is obtained by multiplying the element of second row of first matrix with respective column of second matrix. Means we can multiply first column, second column, and if it is given third column, we multiply with third column. Now let us see here with example. Now A, we are taking a matrix of order 3 by 2, and B is a matrix of order 2 by 3. So we must get a matrix, new matrix of order how much? Row of A is 3 and column of second is 3. So 3 by 3. So how we obtain here, you see, A into B. First you write A matrix, then B matrix. So you will get the element of first row by using first row only. So first row, first column. So how we get it? First row, first column. You will concentrate for the first element. So first element into first element plus second element into second element. So first row, first column. We'll get the first element of first row. So first row is A11, first element, and first element of second first column is B11. So A11 into B11 plus A12 into B21. Now first row, second column, A11 into B12, then A12 into B22. Okay, so first row, first column, first element. First row, first, second column, second element. First row, third column, third element. A11 into B13 plus A12 into B23. Now come first row work is over, so we'll get three elements we got. Similarly, second row will take second row first column, we'll get the first element. Second row second column, we'll get the second element of second row. Second row third column, third element of second row. Similarly, third row will multiply with first column, second column, and third column respectively to get the first element, second element, and third element. So in this way we multiply. Okay. Now let us see, my dear student, how we will find out A into B with example. A is a matrix of order 2 by 2. B is a matrix of order 2 by 3. Now here you are taking first row, first column, 2 into 3, 6 plus 3 into 5, 15. 6 plus 15, we get 21. Say, first row, second column, 2 into 2, 4 plus 3 into 1, 3. 4 plus 3, 7. 2 into 4, 8 plus 3 into 3, 9. 8 plus 9, 17. So like this, we can get the first elements of first row. Similarly, element of second row, we'll get second column with first column, second row with first column, then second column and third column. So second row, 4 into 3, 12 plus 2 into 5, 10. We'll get 22. Second row, second column, 4 into 2, 8 plus 2 into 1, 2, 10. Total to now 4 into 4, 16 plus 2 into 3, 6, 22. So in this way you can multiply, and you will also try this one. Now here one more example I have taken. A is a matrix of order here 1 row 3 columns, and B is a matrix 3 columns 1 row. So we'll get a matrix of 1 by 1. So first row, first column. So only one time multiplication. So 1 into 2 plus 3 into 4 plus 5 into 5. So we'll get 39. Okay, of order 1 by 1. So we'll get a matrix of order 1 by 1, only one element. So this also we have seen, we have multiplied on this example. Order is 2 by 2, and here order is 2 row 3 columns. So we'll get 2 by 3. 2 row 3 columns. Here you see first row first column. First row first column, 1 into 1 1 minus 4 minus 3. 1 into 2 2 minus 2 into 3 minus 6 to minus 4. 1 into 3 3 minus 2 1, like this. second row first column will get 8, second row second column will get 13, second row third column will get 9. Similarly, we can find out 3a minus 5b. Okay, subtraction, so we are getting here all elements 0. Now here we can use in finding x and y. It's like same as solving a linear equation, pair of linear equation in variables. Now here pair of equation in terms of matrices. So here capital X, capital Y, these are the matrices. Now x plus y given x minus y. So very easy to find out x and y. How? By eliminating. So you can eliminate y by adding 1 and 2. Then we will get x equal to 5, 0, 1, 4. Then you can find out from 1. So you can replace x value. So we'll get it as 2, 0, 1, 1. These are easy but important. So you practice this type of question. Next, here one question I have taken. So two matrices addition equal to single matrix. So you are asked to find out x and y. First of all, you will add these two matrices to get 2 plus y, 6, 1, twice x plus 2 equal to 5, 6, 1, 8. So here you see equal matrix. So 2 plus y equal to 5. So we can get y equal to 3. 2 twice x plus 2 equal to 8. So this will give you x equal to 3. It's a easy, so but important. Now here one textbook question we have seen. Fx equal to given cos x minus sin x 0, then sin x cos x 0, 0, 0, 1. Now we have to show fx into fy equal to f of x plus y. Now here fx is given this matrix, then we can find out fy also by replacing x by y. So fx into fy will be these two matrices multiplication. If we multiply this, then we can use the trigonometric identity. Then we'll get cos x plus y minus sin x plus y 0, then sin x plus y cos x plus y 0, 0, 0, 1. This is nothing but f of x plus y. So very easy to prove. Thus, we should apply the multiplication of matrices very carefully. Next is find a square minus 5a plus 6i. Okay. Now here, here you see a square. So first you find out a into a. So a into a you are getting this one. Next we replace here in the polynomial, that is a square minus 5a plus 6i. So a square value is this, then 5 into this will get this matrix multiplying by scalar, then 6i means 6, 0, 0, 0, 6, 0, 0, 0, 6. So we'll get this matrix. Okay, this is like in polynomial we have done this polynomial of matrices. Now here also a and b, a is given and a condition is given a square equal to k minus 2i. So a square we have found, then k minus 2i also we have found. By equality of matrices we'll get the equation here, that is we'll get here 3k minus 2 equal to 1, or minus 2k minus 2. So k equal to 1 will get here. Okay, so here this will give you k equal to 1. From every member you will get 4k equal to 4, k equal to minus 4 equal to minus 2k minus 2 will also give you 1 only. So, okay, so everywhere we should get 1. Next, we can do some statement problem by using matrix method, which, which is very easy. Okay, now here you see is a textbook problem. A trust fund has 30,000 rupees, then must be invested in two different types of bonds. The first bond pays 5% interest per year, and second bond pays 7% interest per year. So using matrix multiplication, determine how to divide 30,000 among the two types of bonds. Now here you see we are having two types of bonds. So one is giving 5% interest. So we'll take in the first bond, suppose we are investing rupees X. In the second kind, we are investing 30,000 minus 6 because we are having total 30,000. After that, we can write now in the first case, here you see, in the first case, in the first trust, obtaining interest rupees 1800. That means we can write in matrix method. First bond, we are having two bonds. So first bond X, second bond 30,000 minus 6. So we are writing in a row matrix. Then we are writing a column matrix of interest 5% and 7%. It should be first bond and 5% first bond, second bond and 7% for second bond. So when we multiply first with first plus second with second, so we'll get the x equal to 15,000 and second bond also equal 30,000 minus 15,000. So in this we can use the matrix multiplication in finding some problems. Okay. Now here one more important question from textbook. The here P and Y are of some order given. Okay. So here is a textbook question number 21. You can see. Now here which option is correct? Now here Py, P into Y and W into Y you are adding. Now here Py is of order P by K and P is of order P by K, Y is of order 3 by K. Then Py is of order P by K because here you are getting K equal to 3 here given. Again W ordered N by 3, Y is of order 3 by K. So W is over N by K. Now we must have P by K equal to N by K. Now here we are given K equal to 3. Now which one is true? So obviously we are having K equal to 3 and here P by K must be equal to N by K. So K equal to 3 and P equal to N. So K equal to 3 and P equal to N is the correct option. That is A. So in this way we'll see. Now here's some important MCQs. Now here you see how many matrices of order 3 by 2 are formed with possible entry 0, 1, 2, 3. How many matrices will get order 3 by 2? So here we are having entry 0, 1 and 2. So 3 by 2 means we are having 6 places. We are having 6 places. So we are having option 0, 1 and 2. So first place we are having 3 options. Second place 3 option. Third place 3 option. Like this 6 places we are having 3, 3, 3. That means permutation idea we can use. So it will be 3 power 6. So your answer will be 3 power 6. Okay, because it is permutation we are applying 3 power 6. Now here by equilibrium matrices you can find out what is the value of y. So y will be how much? Now we can see here 3x minus 2y equal to 3 and x equal to minus 3 by equality. So x equal to minus 3, y value will be how much? So we can replace here value of x. 3x minus 2y equal to 3. Now if I put x equal to minus 3, it will be minus 9 minus 2y equal to 3. So 2y equal to minus 12. So y equal to minus 6. By equality matrices, you can find it out, right? Now let us see. A is a square matrix of then what is A plus A dash is symmetric, skew symmetric, zero, and identity. Now here symmetric matrix and skew symmetric matrix we have to recall. So a symmetric matrix. Now what is symmetric matrix? Okay. Now symmetric matrix means what? A matrix is symmetric. A square matrix. Here we are talking about a square matrix. Okay. A matrix A is symmetric. A matrix A is symmetric if transpose of A equal to A, right? So transpose of A equal to A, then we can say it is what? Symmetric matrix. Okay, now transpose again. We know what is transpose. Transpose of a matrix. How you obtain transpose of a matrix? Transpose of a matrix, how we can obtain? We can recall, isn't it? Transpose of a matrix is obtained by transpose of a matrix. Okay, transpose of a matrix. Transpose of a matrix A is obtained by how? By interchanging rows and columns, isn't it? Transpose of a matrix A is obtained by interchanging rows and columns. Rows and columns. Okay, we can interchange rows and columns to obtain transpose of a matrix. Suppose we are having a matrix of order m by n. We are having a matrix of order m by n. Now, A is a matrix of order m by n. Okay, now transpose of A dash, will be a matrix of order n by n. The order of the matrix will be n by m because we are changing rows to columns and columns to row. So number of row m will become number of column and number of column n will become number of row. Okay. Now here you are asked to check whether A plus A dash is symmetric or skew symmetric. Now here some properties we have to recall for symmetric matrices. Okay, now some properties we can see here for symmetric matrices. Now A dash dash equal to A. Okay, A dash dash equal to A plus B transpose equal to A transpose plus B transpose. A into B transpose equal to B transpose into A transpose. So some properties we can use in finding. Now here you see next. Now here you see, as we have already discussed, transpose of a matrix. So if A equal to Aij of order m by n, then A dash equal to Aji, because we are changing rows to columns. Now here you see A is a matrix of order 2 by 3, then its transpose is of order 3 by 2. ABC was first row, then it becomes first column. Second row XYZ becomes second column. So like this we can obtain transpose of a matrix as it is written as AT, A dash or trans of A. Then property says just now we have discussed. So A dash dash equal to A. Transpose of the transpose of a matrix is the matrix itself. K into A dash is K into A dash. A plus B dash equal to A dash plus B dash. AB dash equal to B dash into A dash. Next is skew symmetric matrix. Okay, symmetric we have seen. Now let us see skew symmetric. Skew symmetric matrix. So a matrix Aij is a square matrix. Okay, in case of symmetric and skew symmetric, it must be square matrix only. A square matrix A is said to be skew symmetric if A dash equal to minus A. So when we take the transpose of the matrix, we should get the negative of the matrix, and Aj equal to minus Aij. Okay, so here one more property we have seen Aij element equal to minus Aj. That means A12 equal to minus A21. Okay, A23 equal to minus A32. So negative of the element A12 will be negative of A21. If A12 is positive, A21 will be negative, opposite sign. And they are equal, but sign is opposite. A23 equal to negative of A32, etc. We can see in case of skew symmetric matrix. And here a diagonal element will be 0 in case of skew symmetric matrix. Diagonal elements of a skew symmetric matrix 0. We may get MCQ question on this point also sometimes. Now this is an example of skew symmetric matrix. So here you see A. So here A12 minus 4, A21 4. A137, A31 minus 7. A23 minus 5, A32 5. So this is a skew symmetric matrix. Now here A plus A dash is always symmetric, A minus A dash is always skew symmetric. Okay, so this you see. Now here A we are taking this one, A dash is this one. So 3, 5, 1 minus 1, then A dash is 3, 1, 5 minus 1. Now A plus A dash if we find, we'll get 3, 3, 3 minus 1. So obviously it will be symmetric. Now half of A plus A dash if we find, then you will get the half of A plus A dash. Similarly, so therefore half of A plus A dash is symmetric. And A minus A dash also we get skew symmetric. So half of A minus A dash also is skew symmetric. Now therefore any matrix A can be written as half of A plus A dash plus half of A minus A dash. So half of A plus A dash, this is symmetric, and this is your skew symmetric. Okay. Therefore any square matrix can be expressed as a symmetric and a skew symmetric matrix. Okay. Now next is some MCQ we can see. Now here A equal to 10, 0, 6, 12, P plus Q, where P is symmetric, Q is skew symmetric, then Q is equal to. Now P is symmetric, Q is skew symmetric. Now here ABCD is the option. Now here you can see which one is skew symmetric. Now first one is not skew symmetric. Second is also not. Third one you see diagonal element 0. Okay. It should be third one, isn't it? Because Q is, you have to find out, and Q is skew symmetric. So here only one, that is C option, is skew symmetric. Now A is a matrix of order 2 by 3, B is a matrix of order 3 by 2. Then if C equal to A into B, D equal to B into A, then order of CD. Okay, order of CD will be how much? A into B, A order 2 by 3, B order 3 by 2. A into B must be order how much? 2 by 3 and 3 by 2 will give you 2 by 2. Okay. So C is AB. So C of order 2 by 2. Okay. Then C of order 2 by 2 and B is order 3 by 3. So CD can we find out? No, we cannot find out. So CD is not defined. Okay. CD is not defined because C of order 2 by 2 and D of order 3 by 3. So we cannot find out. Okay. Now let us see another one. A is a 2 by 2 matrix whose elements are given by Aij is 1 if I not equal to j and Aij 0 if I equal to j. Then the value of A squared. So A we can write down. So A will be how much then? We can write A. First of all, A is a matrix of order 2 by 2. So elements are A11. A11 will be 0. A12 will be 1. Then A21 also 1. A22 0 according to the definition given here. When I not equal to j, it will be 1. We have to take 1. So when I equal to j, diagonal element will be 0. Then you find out a square. So a square if you find out, a square you can find out 0, 1, 1, 0 into 0, 1, 1, 0. So first row, first column. First row, first column will give you 1. Then first row, second column give you 0. Again, second row, first column will give you 0. Second row, second column will give you 1. That will be D. Option will be D. Isn't it? Now here, 4 number. If the matrix A is 0, A minus 3, 2, 0 minus 1, B 1, 0 is a skew symmetric matrix, then the value of A and B is, A value will be how much? If it is skew symmetric, obviously it will be minus 2. A minus 2 and B. B here is here minus 3 and B must be 3. So obviously option is B. Okay, so we'll use the property of skew symmetric matrix. Aij equal to minus Aji. So similarly, this also you can find out for symmetry. You can try it out. Question of 5 and 6. A is a symmetric matrix. So we'll find out the correct statement from here. The diagonal element of skew symmetric matrix are, this we know. Okay, this you will see. Next, if A equal to this is a skew symmetric matrix, then the value of A plus B plus C. So here also you will use the skew symmetric property. Then you can find out A plus B plus C. Next, some short answer and long answer question. So here you can find out x minus y value from this equality of matrices. You can try it out. Now you can prove if A and B are symmetric matrices, prove that AB minus BA is skew symmetric matrix. So this also you can try it out. Then if A equal to this, then show that A cube minus 4A square minus 3A plus 11I equal to 0. Matrix multiplication you can use. Okay, these are some questions given in the Sarna program sample paper, so you can go through. Now let us come to the determinant. Determinant. So determinant means determine is coming from the word determine. So determinant will give you a value of a square matrix. Okay, so determinant function whose domain is a set of square matrix and codomain is real numbers. Okay, if we talk about in the field of reals, then we'll get real numbers. Now here A is a square matrix order 2 by 2. Then determinant of A is obtained by how you see we use in this way. And it is written by using the two parallel lines. So this is the determinant symbol. So here A, B, C, D is written between two parallel lines. So it is written as dt of A, determinant of A. Now here you see how we find out how to get the value of a matrix of order 2 determinant. That is the value. So A is of order 2 by 2, elements are A, B, C, D. Now here how we find out by cross multiply determinant of A in first with the corner element cross multiplication A into D minus B into C. So you have to subtract AD minus BC. Now example here it is we can get it very simple. You know all this, even though we have to recall it. 2 into 3 6 minus 1 into 5 5. 2 into 3 6 minus 1 into 5 5. 6 minus 5 1. Now determinant of 3 by 3. So 3 by 3 is very important. How to expand 3 by 3 determinant. So here we are taking a determinant A11, A12, A13, A21, A22, A23, A31, A32, A33. Now here we expand along first row suppose. So how we expand here you see determinant along first row. Now, how we find out minus 1 per 1 plus 1 into A11 into its minor. So minor means this the element. Is minor is eliminate first row and first column. We'll get the determinant A22, A23, A32, A33. So A22, A23, A32, A33. Similarly, for second element of first row, minus 1 per 1 plus 2 into A12. A21, A23, A31, A32. That is a minor of second element. Second element is this. Delete first row and second column. You will get A21, A23, A31, A3. Similarly, plus minus 1 per 1 plus 3 into A13 into its minor. Delete first row and third column. A21, A22, A31, A32. So this one will get. Next, we are getting now minor, so 2 by 2, we know how to expand. So it will be plus 1 into A11 into this expansion of this 2 by 2 determinant. A22, A33 minus A23, A32. So likewise, minus A12 into the minor of next A13 into this. So in this way, expand a 3 by 3 determinant. Now, if A equal to KB, where A and B are square matrix of order n, then we can write determinant of A equal to K for n into determinant of B. Suppose A matrix A is written as K into B. Then if I take determinant of A, then determinant of KB equal to K for n, because A is of order n. So we can write here K for n outside, then determinant of B. So this one, find the value of X if two determinant are equal. So just you expand 2 into 1, 2 minus 4 into 5, 20 minus 18. Twice x square minus 6 into 4, 24. So you solve it, you get plus minus root 3. This type of question we may get in exam. And properties of determinant, this all we not required. Next is area of a triangle. Now area of a triangle. Now using determinant we can find out area of a triangle. If we know the vertices of a triangle, if you know the vertices of a triangle, you can find the area of a triangle. How? Suppose x1, y1, x2, y2, x3, y3 be the vertices of a triangle. Then area of the triangle is half of x1, y2 minus y3 plus x2, y3 minus y1 plus x3, y1 minus y2. Now here, this formula we got in which class? Can you remember? In class 10, isn't it? Now this expansion can be written in case in the form of a determinant. How? Half of first row x1 y1 1, second row x2 y2 1, third row x3 y3 1. Okay, if you know the vertices x1 y1, x2 y2 and x3 y3, you can find the area of a triangle by using this determinant. Now area is a positive quantity. Always take the absolute value of the determinant. If area is given, use both positive and negative value of the determinant for calculation. The area of a triangle formed by three collinear points is 0. Means if the area of the triangle is 0, then points are collinear. If points are collinear, then area will be 0. Now here, find the area of the triangle with vertices 1, 0, 6, 0, 4, 3. So we can just place half x1, y1, x2, y2, 1, x3, y3, 1. Put and expand, we'll get the value of area of the triangle. Now here sometime you may ask to find out value of K. Now here area of the triangle ABD is given 3 square unit, vertices given 1, 3, 0, 0 and another one is given K0. So K value we have to find out. So 0, 0, 1, 1, 3, 1, next xy 1 equal to 0. Now here equation you have to find out, find the equation line joining this 1, 3, 0, 0 using the determinant. So you will take any arbitrary point Pxy to get the equation. So first you will found the equation. Then find K if D is a point such that area of the triangle is 0. Then only you can, area of the triangle is 3 square unit, not 0. So 3 square unit, we are taking plus minus 3 because here magnitude is given, but direction we may take plus minus. So in this case, area of the triangle will take plus minus 3. So you take half of your vertices are 1, 3, 0, 0, 0, 1 and K01. D point is K01. Now you're expanding, you are getting minus 3K by 2 equal to plus minus 3. That is K equal to minus plus 2. Okay? Or plus minus 2. In this way you can find out. Now minors and cofactor of a determinant, which is very, very important, minors and cofactor. Just we'll see. Now here, minor of an element. The minor of an element in a determinant. The minor of an element Aij of a determinant obtained by deleting ith row and jth column. Okay, in which the element Aij lies. The minor of Aij is denoted by Mij. Mij. M is minor, so we are writing Mij. So here you see cofactor. Cofactor is nothing but cofactor of small aij is written as capital Aij, and it is written as Aij equal to minus 1 for I plus j into Mij. So if I plus j is even, then it will be positive. If it is odd, it will be negative. So suppose, for example, find the minor and cofactor all the elements of the determinant. 1 minus 2, 4, 3, 2. First element 1 means A11. A11 minor will be M11. So M11 will be 3. Similarly, A12 will be minor of A12 means your minus 2 will be 4. Delete this row and column, you'll get 4. Similarly, M21, so it will be minus 2. M M22 will be 1. Now here, one important property, sum of the product of the element of a row or column with corresponding cofactor is equal to determinant, otherwise 0. That means if we multiply the elements of a row with its corresponding cofactor, then we'll get a determinant A. First row element with cofactor of first row, corresponding cofactor of first row will get the determinant of A. Similarly, second row elements with corresponding cofactor of second row, then we'll get equal to what? Uh, the determinant of A. Okay. So here that means A11 into A21, A12 into A22 plus A13 into A23 equal to 0. For a determinant, because we are multiplying A11, A12, these are the element of first, what? First row, and A21, A22, A23, these are the cofactor of second row. So it will be 0. But also A11 into A11, A12 into capital A12, A13 into capital A13 will give you the determinant of A, because you are adding the product of the element of first row with the corresponding cofactor of first row. So this will give you the determinant of A. Now adjoint of a matrix. Now adjoint of a square matrix, how we find out is adjoint of a square matrix is nothing but transpose of the cofactor matrix. That is matrix formed by the cofactor. Okay, so adjoint of a matrix is denoted by ADJ. That means ADJ means adjoint of A is nothing but transpose of cofactor matrix. Suppose A is the cofactor, then take is transpose. Okay, so transpose of cofactor matrix. Now here, for any matrix A, you are taking matrix A is this one, then adjoint of A is transpose of matrix formed by the cofactor. Cofactors of first row are A11, A1 to A13, second row A21, A22, A23, third row A31, A32, A33. Now here, take the transpose. If I take the transpose, first row will become first column, A1 on A1 to A1 3. Okay, it's already written transpose, so here no need to write down. So transpose is first row will become first column, second row will become second column, third row become third column. So in this way, you can find out adjoint of a matrix. Now here, one important formula. Let A be any given square matrix of order n. Then A into adjoint of A into A equal to A into I, where I is the identity matrix of order n. So this can be proved also. A is this is the adjoint of A. If you multiply, first row, first column will give you determinant of A. Then first row, second column will give you 0 because you're multiplying the element of second column with this one, cofactor of second row. Okay. A first row element we are multiplying with second row cofactor will be 0. Similarly, first row element with third row cofactor will be 0. Similarly, this one also will get 0 determinant of a 0, 0, 0 determinant of a. Now, determinant of a is common, so it will be like this determinant of a into I. Therefore, a into adjoint of a into a equal to determinant of a into I. So similarly, this one, some definition of a singular matrix. A square matrix A is said to be singular if determinant of A is 0. And it's non-singular if determinant of A not equal to 0. Now here A and B are two non-singular matrices of same order. Then A, B and B are also non-singular matrices of same order. If A and B are non-singular, their product is also non-singular. Determinant of product of matrices is equal to product of their respective determinants. Means determinant of A into B equal to determinant of A into determinant of B. Okay. Next theorem. If A is a square matrix of order n, then determinant of adjoint of A equal to determinant of A power n minus 1. So here A is a square matrix and A is invertible only if A is non-singular matrix. Okay, this is another one. Now here, proof also given here. You can see A be a invertible matrix of order n, I be the identity matrix of order n. Then there exists a square matrix B such that A B into B equal to Y. So A B into A into B equal to Y, determinant of A into determinant B equal to I, so determinant of A into determinant B equal to I equal to 1. Now hence determinant not equal to 0, hence A is non-singular. Conversely also we can prove A be non-singular, then we can show B is non-singular. Okay. So this way we can prove. Now A inverse how we find out from this. A into adjoint of A into A equal to determinant of A into I. If I go through this, so I equal to, we can write A into adjoint of A by determinant of A. So this part we can consider as B. That is A inverse. So A inverse equal to 1 by determinant of A into adjoint of A. So this is very, very important in solving a pair of system of linear equation. Or this also one theorem AB inverse equal to B inverse into A inverse. This also can be proved. Now here how to find out inverse of a matrix, here it is given. First of all, you'll find out determinant of A equal to 1 non-singular, hence invertible. Then you'll find out all the cofactors A11, A12, A13, A21, A22, A23, all you'll find out. Then you will find out adjoint of A. Okay, adjoint of A you will find that is transpose of the cofactor matrix. You got this one. Then A inverse is adjoint of A by determinant of A. Okay. So this one we can use. Now here also another way also you can find out A inverse. How? So that this matrix satisfying this equation. Okay, you can show this equal to 0. Then find A inverse. So you'll use this equation in solving for A inverse. So we can solve like this. A square means A into A minus 4A equal to minus I. So minus I, so you can write it as uh, A into, or you're multiplying A inverse on both the sides. So A into A into A inverse. So A into A inverse I. So A into I minus 4 into I. So A minus 4 equal to minus A inverse. So A inverse equal to 4I minus A. So this you can find out. Okay. Now here let us see what we have seen. A inverse means adjoint of A by determinant of A. You remember this, which is very, very important. Okay. Now here AB inverse equal to B inverse into A inverse. This can be proved. So A inverse adjoint of A by determinant of A. Adjoint of determinant of adjoint of A, where A is a square matrix order n. Okay, this can be written as determinant A power n minus 1. So this here we can, in this term we can see here three unknown quantity. Okay, here three unknown quantities are there. What are the unknown quantity? Can you tell me? Okay, so here unknown quantities are adjoint of A equal to determinant of A power n minus 1. So here three unknown quantity. One is determinant of adjoint of A, one is determinant of A, and one is n. Okay. So therefore, what you do is, if any two quantity are given, you can find out the third one. For example, suppose A is a square matrix of order 3 by 3 and determinant of A equal to 5. Now, what is the determinant of adjoint of A? Like this question we may get. Simply you can write down this, use this formula. Adjoint of A, determinant of adjoint of A equal to determinant A power 3 minus 1, 2 means 5 squared. So that is 25. So this type of question we may get. Okay. So my dear students, this transpose of a matrix, inverse of a matrix, and minors cofactors. So all you go through very properly. So now you can solve also this type of system of equation. Okay, you can try by using matrix method. Okay, now you will solve this. Okay, you can try solve for x and y. Y6 plus y equal to 5, x minus y equal to 7. Okay, simple question I am giving. Next is solve for x comma y comma z. Suppose x minus y plus z equal to 2, x plus 2y equal to 3. Next is x plus y minus 2z equal to 5. Okay. One more you write down. Sometimes we may get this type of question. You see question number 3. Okay. Now we are having some questions like this. We may get in exam also this type of question. Use the product. Use the product 1, 1, 2, then 0, 2, 3, next 3 to 4 into 201 923, next 612, to solve the system of equation. To solve x minus y plus 2z equal to 1, twice y minus 3z equal to 1, then 3x minus 2y plus 4z equal to 2. Okay. So this type of question, now you can solve this equation by using this product of matrices. Here you will see the matrix, one matrix is coefficient matrix of the other. Okay. So here sometimes, here one correction is there. He can put a minus 3. Okay. Then 3 minus 2y here, minus 1 minus 1 2. So here first row is the coefficient of first equations. Second row are the coefficient of second equation. Third row is the coefficient of third equation, like this. So this you will solve. Okay. My dear student, revise properly for the board examination so that you can do well in the chapter matrices and determinants. Hope you can score full marks in this chapter. Okay. So thank you. Thank you everyone.